Now we explore an alternative to long division of polynomials called synthetic division. This process is much faster than long division. Not that you can't get fast at long division, you certainly can do that pretty quickly once you get practice. But synthetic division is nice for a couple reasons that we'll see soon enough. But when you trade in something for a simpler technique, oftentimes that simpler technique is limited, and that's precisely what happens with synthetic division. With synthetic division, you can only divide by certain types of divisors. And so those divisors have to look like this. They have to be x plus or minus a constant. And so it has to be x to the first, and it has to have a coefficient of 1 in front of the x. In any other case, you'll need to use long division instead. So it's very limited in what it can do. Now there are ways to deal with this if it's x to the first, but you have a coefficient other than 1. I'm not going to get into that here because that's not necessarily the purpose of this video, but I might do a follow-up video later on if anyone's interested. Okay, so we can only divide by x plus or minus a constant. So let's try this out. Let's try to divide, let's do a quartic polynomial, degree 4 polynomial. How about 3x to the fourth minus 2x squared plus 5. Let's divide that by, how about x minus 1? We'll keep it simple. And so you can see the divisor here is x plus or minus a number as we need. So this qualifies for synthetic division. Now, much like with long division, if you want to do this, you have to incorporate placeholders for any terms that might be missing. Okay, so this 3x to the fourth minus 2x squared plus 5, we're going to write it with 0 placeholders where terms are missing. So we're missing an x cubed term, and we're missing an x term. So we're going to call that 0x cubed and 0x, okay? So this is the same thing as 3x to the fourth plus 0x cubed minus 2x squared plus 0x plus 5. And so when we translate this to our synthetic division, one of the advantages of synthetic division is you don't use any variables at all, okay? And so if I want to represent this polynomial in synthetic division, I literally represent it with just the coefficients 3, 0, negative 2, 0, and 5. So when I write this, I write 3, 0, negative 2, 0, and 5. Now again, there's a trade-off. When you lose the variables, the work becomes much faster. But then when you go to develop an answer when you're done, when you need to interpret your work, it's harder because you've got to put x's back in. So we'll see that soon. And we'll kind of give a preview now. So if I gave you this in synthetic division, the question might be, how would you know that this represents the original dividend? And the answer is, well, the pattern is you incorporate 0 placeholders and you always go in descending order. So you go down a degree each time until you reach your constant. So the way to rebuild it would be to start back at the last number you have, which would be your constant. So this would be a constant of 5, and then you go up to x, then x squared, x cubed, and x to the fourth, and you could see that would rebuild the polynomial. Okay, so that's representing the polynomial. Now the next big difference with synthetic division is you invert the division bar like this, instead of putting it over the top. Okay, so here's our dividend. We still put our divisor out here. This is the biggest troublemaker with this process. The divisor that goes out here, you would think it would be 1, negative 1. Those are the coefficients here. But because divisors are always in this form, we don't even represent the x at all. We don't write that out at all over here. We just represent it by the constant term. And in fact, you have a couple choices. You could use the constant term directly and make this a negative 1, or you could use the opposite of it and make it positive 1. Now, most textbooks I've worked in will take and they will change the sign of this and make it positive 1. What that's going to do for us, I'll point out as we move along here. But the way to think about this is positive 1 is the 0 of this. So you always put the 0 here. okay? And it happens to always be the opposite sign of what you're dividing by. So if you see a 1 out here, that means you're dividing by x minus 1, okay? All right, now, beneath the division bar, you're working down now. You're going to have one empty row, then you'll have a horizontal line with another empty row. The answer to this problem is going to be the numbers that you get on the bottom row. Okay, so the process for doing synthetic division, let's jump into it now. The first thing you do is you drop the leading coefficient. You drop the leading coefficient. So that means I'm going to drop my 3. I'm going to drop my 3 here to the bottom row. That's going to be the first part of my answer. And then after that, you repeat a process. You repeat this process. Multiply and add. Multiply and add. So I'll show you what that looks like. So just like with long division, you always multiply by your divisor. You do the same thing here. So you take 1 times 3, and that result goes here. So you do 1 times 3, and that's 3. Then you add the column, so plus. 0 plus 3 is 3. So there's one iteration of this process. Then you do it again. You take the divisor 1 times this 3, which is also 3, put it here, and then you add to get positive 1. Now you get the idea. I take 1 times 1, which is 1, and I add. Then I take 1 times 1, which is 1, and then I add. And that's it. That's the dividing. We're all done. Now, the beauty about using the 0 of this over here, using positive 1 instead of negative 1, is that we add in the columns. We're much better at adding a lot of times than we are subtracting. If we did use a negative 1 here, then we would have to subtract all of these numbers. Okay, so you could play around with that if you'd like to, if you're worried that you're going to get confused about using the 0. In my videos, I will use the 0 and be consistent. All right, so this is what we have. What does it mean? Well, let's sort of break down the result. The bottom row is our result. This number on the end, I always kind of like to put it in a box like this. That's our remainder. That's how much we have left when we do this division. And then the rest of this is our quotient. This is our quotient. Now there's a couple ways to interpret what this is saying. You can do like I said before. If this is a polynomial, then this last term is a constant, and then you've got x, x squared, x cubed. X squared, x cubed. And you can put it in the pluses there if you like. The other way to do it is the original polynomial was 3x to the 4th, and we divided by x to the 1st, right? This was x minus 1 over here. When you divide x to the 4th by x to the 1st, the answer is going to be x cubed. So that's another way to do it. You could build it from the left to the right. Anytime you divide in synthetic division, your degree, the original degree, is going to go down by 1 because you're always dividing by x. Okay? So, in any case, that's how to interpret the result. How could you write the meaning of this now? You've got a couple ways you could write the meaning of this. One way you could write the meaning is you could rewrite the dividend. You could rewrite the dividend. So in this case, 3x to the 4th minus 2x squared plus 5 equals, when we divided it by x minus 1, so it equals x minus 1 times the quotient, 3x cubed plus 3x squared plus x plus 1, plus the remainder of 6. So if you multiplied out these two polynomials and added 6, you should get the original dividend back. So that's one way to interpret the result. Another way is to rewrite the division. Rewrite the division. So in this case, we're dividing 3x to the 4th minus 2x squared plus 5 by x minus 1. And so when you divide this, how many times does x minus 1 go into this 3x to the fourth minus 2x squared plus 5? Well, it goes in the quotient amount of times. So it's going to equal 3x cubed plus 3x squared plus x plus 1, right? That's our quotient, plus our remainder divided by the divisor, x minus 1, okay? Now with synthetic division, as far as I'm concerned, the most common way to use it is to rewrite the dividend as such. Because if, for example, the remainder here were 0, then that would allow us to know that, hey, we've got it factored now. In other words, x minus 1 would be a factor of this polynomial, okay? So that's probably the most common use, but it's good to look at both. Now, let's work a problem, work one more problem, but a different question. A particular use of a polynomial. Or a particular use of synthetic division. We can use synthetic division to determine if a number is a 0 of a polynomial. So we can use it to divide, purely to divide, but we can also use it to determine if a number is a 0. So let me show you that. Determine if 2 and 3 are zeros of x cubed plus 8, okay? So we're going to do both of these two different ways. So the first way is the most basic way, and it's really simple. All we have to do is, if I want to know if a number is a 0, all I have to do is plug the number in for x and see if I get 0. So option 1. Option 1 is plug it in, okay? So in this case, if I plug in 2, sorry, I meant negative 2. Determine if negative 2 is a 0. So plug in negative 2, so I get negative 2 cubed plus 8, which equals negative 8 plus 8, which is 0. So negative 2 is a 0, okay? Now plug in 3, and I get 3 cubed plus 8, which is 27 plus 8, which is 35. So 3 is not a 0. Now, very simple to do it this way, okay? No problem with that. And in fact, in this particular example, that's going to be the easier way to do it. Option 2 is with synthetic division. So if I want to know about negative 2, then I make negative 2 the representative, the potential 0. Remember, this is a 0 of some polynomial, and I need to divide that into my x cubed plus 8, which if I write that out, it's 1x cubed plus 0x squared plus 0x plus 8. And then I run through the division, and if I get a remainder of 0, then that means this number is a 0. So let's run through the process. Drop our 1, multiply, add, multiply, add, multiply, and add. So in this case, negative 2 is a 0. Now that was a longer process than what we did over there. Okay, so that's something to think about. 3, let's do the same thing with 3. We get 1, 0, 0, 8. Drop our 1, and then multiply and add. So drop the 1, multiply, add, multiply, add, multiply, add. This is not 0, so 3 is not a 0. Okay? Now, Notice that the remainder here was the same output we got when we plugged the number in over here, and that 0, this remainder, is the same output we got here. That's not a coincidence. That will always be true. So when you do your synthetic division, all you're doing is multiplying and adding. When you plug a number into a polynomial, you have to do powers, which can be harder, can take more time. In this case, it's not bad. But let's try another one really quickly. I think you get the idea, but I want to show you one where it might be easier to do synthetic division. So let's determine if -2 is a 0 of x cubed plus 4x squared plus 4x, and we'll leave it at that. Determine if -2 is a 0. So one way to do it would be to plug -2 in. So that would be -2 cubed plus 4 times -2 squared plus 4 times -2. So that would be one way. The other way would be to use synthetic division. We've got 1x cubed, 4x squared, 4x, and a constant of 0. So let's run through this first. Drop the 1, multiply and add. So we know that -2 is a 0. Multiplying and adding is pretty fast. Now this one's also not bad again in this example, but I think you'll see that this probably requires a bit more work. -2 cubed is -8, plus 4 times -2 squared is +4. 4 times -2 is -8. So we get -8 plus 16. -8 plus 16 is 8. Minus 8, which is 0. And so we can also see that -2 is a 0 this way. Now, there may be times where you prefer one over the other, but it's always good to have more tools in your bag that you can use.